Okay, so for my technical presentation, I'll be going through cellular network. So just start off with what is a cellular network? So it's a wireless communication system that divides geographic areas into small regions called cells, and each is served by a cell tower or a base tower. So the cells work together to provide seamless voice, text, and data services as the user moves between them. So overall, it's a very similar concept to a wireless access point, however, at a much larger scale. So it's kind of the evolution of a cellular network. So first we have the 1G adopted in the 80s. It's analog voice. Its max speed is 2.4 kilobits per second, and it's the first mobile voice call. Next we have the 2G adopted in the 90s, and it moved from analog to digital voice, and its data speed ranges from 64 to 128 kilobits per second. And this is where SIM cards are introduced. Then we have the 3G, created in the 2000s. The key feature is it uses packet switch data. Its normal speed is around 3 megabits per second. And this is kind of like the introduction to mobile internet. Next, we have the 4G, adopted in the 2010s. It moved, you now use all IP. Its max speed is 100 megabits per second. And this is kind of like where video streaming, watching videos, and applications kind of started. Now we have the 5G created in the 2020s. It's a high frequency, low latency, and it has a speed around 1 gigabits per second. It's mainly used in autonomous systems or autonomous systems began using 5G and also LOTs. 5G expected in the 2030s. Um, Key features kind of integrate AI and quantum core, and then its theoretical speed is 10 megabits per second. So components. So first we have the mobile phone. Each mobile phone contains an IME. It's a hardware ID, kind of very similar to a MAC address on an interface. It contains radio antennas, modem, and baseband processor. We have the SIM or subscriber identity module. It's a secure microchip that stores unique IMSI and a secret key. It acts like a digital ID card for the network. Now we have the radio access network or a RAN. It's a towers or base stations that transmit or and receive signals controlled by base station controllers or a G node BS in 5G. Now we have the core network. It's a backbone that connects towers, routes data, manages cells, and authenticates users. It handles the mobility, billing, and security. So the core network is still within the carrier itself. It also handles external network. The process. So these are kind of like the basic steps for a connection. Each of them you can go into more, but this is kind of like the basic concepts. So start off with the phone startup and network search. So when the phone powers on, its baseband modem activates. The SIM card, or these days eSIMs are mainly used. So the phone it's read by the phone's operating system. The SIM provides kind of two key information: the IMSI, the International Mobile Subscriber Identity. It's a user per minute subscriber number. The home network ID, which indicates the country and the carrier code. So the phone scans all the frequencies for a base tower or a cell tower. It listens for a broadcast signal that identify each network, called I or PMLMN, Public Land Mobile Network. It chooses that matches the SIM's carrier or approved roaming partners. Cell selection and registration requests. So once the phone picks a tower, it sends a registration request message to the base station. So it sends the IMSI, the phone IMEI, and request for service. The tower forwards this to the core network. At this point, the carrier starts verifying the user. So for the authentication security handshake, so the carrier or the base station, the cell tower sends a random number to the user. It uses the key from the SIM card and random number from the carrier to compute a response using an algorithm or using an encryption algorithm. It sends back to the SRES. So at the same time, the carrier computes its own version using the key stored in the AUC database. So if both of these matches, so the authentication was successful, otherwise it fails. After the authentication, both sides agree on a encryption key. The SIM and the network creates a session key. This key is used to encrypt radio traffic between the phone and the tower. This protects attacks against eavesdropping, data tampering, and man-in-the-middle attacks. So other keynote, so the billing and the monitoring. So every session, the voice, text, and data creates a call detail record, this or the CDR, the data record UDR. This includes the time, duration, bytes used, and the the tower location. It sends it to the billing system for charging and analytics, and that is all.